Hello everyone and welcome to the third chapter of this video series. In this video we're going to start looking at rendering fire using Houdini and Arnold, and we're going to be using the simulation I have here and trying to achieve the same result I'm showing in this video. Now this fire is a little bit more complex than the explosion I showed before, though it uses a very similar technique. The only difference is that we need to do a little bit more advanced stuff in the shader to be able to capture all the details I'm seeing here and to be able to have some nice illumination and scattering effect going on. So this one on the left is just the fire by itself, and this one is the fire illuminating some geometry around it, and we can see the interactive lighting as well. So let's start by taking a look at the scene. Here I have the geometry, which I'm going to use as matte object. I have a camera, and that's pretty much it. Now, before I bring in the sorry, I have the GUI used, but we're not going to use that for now. So before I start importing the data into Arnold, I'd like to verify it and take a look at what we have here, because we don't know. Imagine this is something coming from the effects department. They will just hand us a VDB file and it's our job to recreate that. So let's take a look at the VDB file and show you guys how I look at the data and see how I can make use of it. So inside this subnode, I'm reading the VDB file that was delivered to me, and I'm gonna check and see what kind of information we have. In this case, we have a density field, we have fuel, we have heat, temperature. Now I'm not sure what exactly in the fuel and heat and temperature. I have to view them and see how useful will that be for my render. So what I've done here is I created 3 volume visualize node, and I'm gonna use a gradient to preview each one of them. In this case, let's start off with the fuel field, and I believe this is what is used in the simulation to emit the fuel into the simulation. And as you can see, that's the only stuff we have here. That's the only thing we have. The second one is the heat, and I think this is something useful. I think I can see a lot of details here already. I can switch this to a high res, a little bit more high res, to show you guys the amount of details I have. There's a lot of information that we can use in our shader, so that's gonna be useful for us. And the third one is temperature, and this one as well looks useful to me, so we're gonna try and use that as well. So I'm trying to use a high res. Yeah, so there's a lot of details that could be nice to have. The last one, most of the time people will say fire simulation only have a temperature and a heat field, and that's what you need to use. But that's not true. I mean, there is density, there is smoke that gets generated by the simulation. It depends on the kind of fire you have. Will affect how much smoke you're gonna have. And for me to get this nice, maybe it's not too clear, but to get the this nice glowy effect around the simulation, I needed to use density, and that's how I'm getting this black border as well. So I will add, you can see it here already, and this is the actual render. There is no compositing happening on any of it. So you can see here, all of this is density field being affected. So we're gonna make use of the density field as well, and you can see there is a lot of information in there. This probably is displaying a lot of things. So let me just isolate the so I think we have density. Let's use visualize node on top of this. this. So we only have the density, and let's change the background to something else, so it's not black. Density, maybe it's too low. I'm not sure we're supposed to be seeing. Oh, there it is. Sorry, I was in wireframe. So we have density. It's not too visible, but we're gonna use that in our sim. Cool. So now that we know that we're gonna be using these two guys, heat, temperature, and density, I'd like to run that volume max on them as well and get an idea of what's the range of each one of them. And I'm gonna show you the command again, and I've done the homework before for this. So volume max, and again this function only works on VDBs, so we need to convert the volume to a VDB volume. This only works on Houdini volume, so we're gonna change that, and I'm going to run it one more time, and it's middle click. So let's run it on the heat, for example, which is number 2. Okay, so we have 4.7 at this frame. It's reading 5.6. 5.7. So I've already run the volume max on each one of these, these two, the ones that we're gonna use, and the density as well. And this is the value I come up with. Density 0.14 is the max, temperature is 30, and 5.7. Even though I'm not so sure about the temperature, because if you look at my render here, it's gonna get white spots in it here, especially here. It got super bright, and you can see that super bright area, how it affects the indirect illumination. So I think I'm not capturing all the details of the temperature field, but that's fine. In this case, I'll leave that to you guys to explore this, and I'd like to show these kind of things so it's not perfect, and it leaves room for the user to try things as well. So I'm gonna copy this, and now I'm gonna create the Arnold volume node and bring in the VDB files. So I'm gonna copy the path here. This is my fire VDB, and I'm gonna read density, heat, temperature, and I'm gonna change this to volume. I'm gonna hide this, I don't need it, and this is my volume now. And I'm gonna create an Arnold node and select the camera, copy this as I did before, and set it to always on top. And now we can go to the render view and hit render to get an idea. So it's rendering, but because we don't have any lights, which we're not gonna use, we're not gonna use any lights in this case, we're getting the volume. So we're gonna start creating a custom shader for this, and we'll continue that in the next video because it's gonna be a little bit longer than usual. So I'm gonna stop here and continue in the next video. Thanks for watching. See you guys.